Assalamualaikum warahmatullahi wabarakatuh. Today our group will present about a probability. But before that, I will introduce myself. My name is SYARIFAH binti ROSLAN and my matric number is 2022807904. And this is my teammate.
Hi, Assalamualaikum. My name is NADIA WAHIDA BINTI YUSOFF.
Hi, my name is NURUL binti SABRI.
Assalamualaikum warahmatullahi wabarakatuh. My name is NURUL IZZATI binti SYUKUR.
For question 1, spin the spinner. Method that we need to use is using a wheel that contains 6 colors, which is they are blue, orange, white, yellow, pink, and green. We need to spin 30 times using table to record the frequency of 30 outcomes. After that, we calculate the probability of each color to be picked using the outcomes. Answer all the questions given. For question 1A, we need to observe and record the frequency of each color. Outcomes white, we've got 7. Blue, we've got 3. Green, we've got 2. Orange and pink, we've got 9. And yellow, we've got 0 for the data. After we record the frequency from question 1A, we need to answer the question 1B, which is the experimental probability of the spinner landing on each color. As we know, we need to spin 30 times. So the frequency need to over the 30 times that we spin. For outcomes white, we've got 7 over 30. For blue, we've got 3 over 30. For green, we've got 2 over 30. For orange and pink, we've got 9 over 30. And yellow, we've got 9. And we calculate all the experimental probability and it should be equal to 1. For question 1C, we need to answer the theoretical probability of the spinner landing on each color. So as we can see, all the colors we've got 1 over 6. Because in theory, if there is even a 6 color or 7 color, there will be 1 at least outcomes. So the probability for all the colors to be calculated is 1 over 6.
For question 1D, the question asks the difference between experimental probability of the spinner landing on the pink section and the theoretical probability of the spinner landing on pink section. Experimental probability of the spinner landing on the pink section is 9 over 30 and theoretical probability of the spinner landing on the pink section is 1 over 6. To answer that question, you only need to take experimental probability and then minus it with theoretical probability, which is 9 over 30 minus with 1 over 6, and the answer that we will get is 2 over 15. As we get the answer and we want it to be in percentage, so we need to take 2 over 15 and then times it with 100. So the answer will be 30%. For question 1E, the question asks the difference between experimental probability of the spinner landing on the green section and the theoretical theoretical probability of the spinner landing on the green section. For experimental probability of the spinner landing on the green section is 2/30, and for theoretical probability is 1/6. So to get the answer, we need to take 2/30 minus with 1/6, and the answer that we will get is -1/10. As we want the answer to be in percentage, so we need to take -1/10 times with 100, and the answer that we will get is 10%. For question 1F, the question asks the difference between experimental probability of the spinner landing on the white section and the theoretical probability of the spinner landing on the white section. Experimental probability of the spinner landing on the white section is 7/30, and for theoretical probability is 1/6. To get the answer, we need to minus 7/30 with 1/6. So the answer that we will get is 1/15. To get the answer in percentage, we need to times it with 100. So the answer will be 7%. For question 1G, the question asks the experimental probability of the spinner not landing on the pink section. So we need to take 1 minus 9/30, as 9/30 is the experimental probability of the spinner landing on the pink section. So the answer that we will get is 7/10.
Now, question 2. Probability density function X is given as shown in the slide. And question number 1. Show that the moment rating function of X is mxt equal to 2/2 minus t. Question number 2. Find the mean and variance of X using answer in part 1. Now, show that the moment generating function of X is mxt equal to 2/2 minus t. As we know, mxt equal to e exponent tx. The expected value of e exponent tx can be computed as follows. Okay, firstly, we just write the formula, which is integrate exponent t as fx of x with respect to x, and don't forget the limit, which is 0 until positive infinity. And then we just substitute the fx of x based on the question, which is 2 exponent negative 2x. Then we put constant at the front. We got 2 integrate exponent t minus 2x dx. For the next step, we just integrate the function. We got 1/2 minus t exponent t minus 2x. And then we substitute positive infinity and 0 into the bracket. We got 2 times 0 minus 1/2 minus t, and the final answer is 2/2 minus t.
Next, we move to the question 2 Roman. For question 2 Roman, we need to calculate the mean and the variance of x by using part 1 Roman. So for the mean, we need to differentiate the moments. We will differentiate 2/2 minus t, and t is equal to 0. And we will get -2/2 minus t square. We replace t with 0 and we get -1/2. Next, for variance, we need to use the formula expected of x square minus expected x square. And first we need to find the expected of x square. So we need to do second differential of moment, and we will get -4t plus 8/t square minus 4t plus 4, and t we will replace with 0. And the final answer for expected of x square is 2. So for variance is 2/7 minus negative 1/2 square, and the final answer is 7/4. So the mean is negative 1/2 and the variance is 7/4.